Today I'm going to talk about the sequence and series. What is the difference between them? And this topic or this chapter will be taught in calculus, and mainly we talk about something called convergence divergence. But let us get to understand what is sequence and series and what is the difference. Sequence is a list of number. Let's say I have this number 2, 4, 6, 8 until a sub n. And this is a list of numbers whereby a series is all these numbers add up together. The sum of the sequence and so forth. And this is so-called a series. So, if you learn the so-called progression before, we have like the arithmetic and the geometric series. And for sequence here, let's say for this term, I can write an is equal to 2n. And we want to list down the thing. Sometimes we can write like this. Element of an, I use this bracket, is an element from 2, 4, 6, and so forth. And sometimes we also can write in this way, whereby the element is 2n. We start from n is equal to 1 and go to infinity. And this is how we say so-called sequence and the series. And then about geometric series, and we have is about times. And we have arithmetic, which is about addition. So for above this series is plus 2, plus 2, plus 2, and it's called arithmetic. If times 2, times 2, times 2, then it's so-called is geometric. Okay. And the whole thing we're going to talk about for this, we're going to talk about is about convergence and divergence. So what the heck is about convergence and divergence? Let me give an example. Let's say we take light. If the light converge, so if it forms something just like laser beam, it just focuses at one point, right? Laser beam is a beam of light that focuses in one point. This is so-called, we say the light converges. Another way we say it focuses. All right. How about if light diverges? If light diverges, it seems like we have an LED light, and the light will be spread all around the room. And this is we call the light diverge, or it means it's spread up to all around, and this is called divergence. And it's the same concept when we have very different number. When is it converges and when it diverges? If let's say we have a function, this function, when the number increases, let's say this is x, this is fx. And when this x increases until the point we say so-called infinity, starting from 0 to infinity, and we have multiple points. And it started going up, going up, going up, and it gradually formed here. So as you can see, the graph we plot here, it might somehow going infinity and stop at this point. Let's say this is L. So we say that this function is convergence. So how about divergence? Let's say we have another function. When when the x go to infinity, we go from 0 and go to somewhere else, almost go to infinity. And it's not going to come down or not going to settle down at a point. And in this case, we call this as divergence. Or this function diverges. By this function, come to an n focus point, is called convergence. Another sample of the point converges is it is not necessarily start from 0. It can be going down like this. And approaches means when this function approaches infinity is, let's say this function, I say when the limit, because the reason why we have to set limit, because when the number we doesn't set limit, we go to very big, go to infinity. Then we can say, we can set some limit. X approaches infinity, and this is near to getting a 0. When it goes to infinity, it's almost like 0. I write nicely. When almost go pointing to 0, but it not touches, but just approximate, nearly the touch becomes 0. And when the function focuses at the 1 point, we say this is called convergence. Okay. So convergence is very simple. If the function focuses at 1 point, let's say at a point which is L, and we call it convergence. And if it does not focus and go anywhere else, and this is called the divergence. All right. So we have to test out the function for the sequence and series, whether the function is converges or it diverges. So I can list down here for sequence and for series. And what are the tests of them? And I'm going to separate this whole series into a few videos. And for each method, I will have one video. So for sequences, we have a method called the sandwich theorem. And we have L hospital rule. And we have a table or common list that we can refer to. And we can use the table to solve for sequences where there's convergence or divergence. And whereby for series, we can solve by geometric itself. Geometric series is whereby it depends on the common ratio. And we have integral test. Means we need to transform the series into the integral. And comparison test. And this is almost similar to the sandwich theorem, almost similar. And we have the limit comparison test, and we have the ratio and the root test. Okay, so we're gonna look at the next video. I'm gonna talk about the sandwich theorem first. Okay.